Thank you, everyone, for joining us um, for this webinar on the Vocareum AI Labs. My name is David Lin. I'm the VP of Business Development for Vocareum, and we also have Peter Kim, who is from our software engineering team. In terms of an agenda, we will start with a quick overview of Vocareum, followed by a demo of the latest and greatest with our AI labs, and concluding with a Q&A session. We're also going to have a drawing for a gift basket. If you have any questions, feel free to use our chat interface below or through our QA interface, and we will respond through that as well. Okay. Let's see. So first, a little bit about our products. So we have three classes of products. One of the biggest ones right now is our current focus, and it's our notebook for learning AI. We also have account management for AWS, Azure, and GCP. And we also have labs for learning different digital skills, including programming, data science, and data engineering. And we do operate at a very large scale. We have about 2.5 million learners, and we are starting 125,000 labs every day, and almost 12,000 courses. As I mentioned, our current focus is on AI education, and we believe that it's really important to deliver this AI education through hands-on, and then also deliver it through cloud resources. It's really no longer good enough for learners to be working on their laptops, even when there are on-prem data centers, because those are often out of date. Our learners are coming from a lot of different disciplines or different areas. We do have direct relationships with universities, different academic departments. We also have agreements with the various edtech platforms like Udemy, Udacity, Simplilearn, edX, Coursera. And we have agreements with content providers like the Amazon's AWS education programs, including AWS Academy and AWS Restart, that actually distributes curriculum to different universities. And then we do have customers who are, software or SaaS providers who are trying to provide customer training, including Databricks. And then we also, of course, work with extension partners as well, who are not just training the residential or current college students, but also in the continuing education space. So as I mentioned, we feel that it's really important to deliver cloud resources as part of the AI and data education. And so right now we do have the ability to provide access to GPUs, to cloud resources like cloud infrastructure like AWS, Azure, GCP, and then also databases and through Databricks. We are also supporting and working on support for Snowflake and then other generative AI solutions as well. All of these resources, incur some cost. Right, and so we do provide a platform to deliver these resources as part of the learning environment. So as part of our capability is a very rich assessment suite. The other portions are budget management, being able to ensure that learners are getting access to these cloud resources, but making sure that they are using them appropriately for learning purposes, and then also making sure that they are not necessarily responsible for acquiring access to those, and those would be delivered through our partners. And then integration into the learner environments, being able to integrate to language or to learning management systems, LMSs, as appropriate. So it could be to a Canvas environment, to an edX environment. And then we also provide a persistent work area, which allows learners to come back to the work over time. So it's not necessarily just a single session, but perhaps it can be longer projects that may last across multiple sessions, multiple weeks. And a key piece is also, when we're trying to provide a digital skills platform, to be able to provide large data sets too, because learners aren't just learning simple skills, but they need to integrate these skills or to master these skills in real environments and being able to provide larger data sets. We also have folks who are using our platform for research, and being able to deliver these data sets becomes very important. And then, of course, learner analytics, being able to see how your learners are doing over time. In terms of assessment options, we provide, as I mentioned, a really broad range. So being able to provide auto grading via scripts. So if you are teaching at scale, like many of our customers are, being able to assess 1,000 learners, you can't do it through TAs. Or if you're teaching on-demand courses through the edX platforms or Coursera, you need to be able to provide feedback to learners automatically. At the same time, being able to provide manual feedback is really important, because obviously you want to provide feedback that's relevant to the learners if needed. Built-in plagiarism detection, inline comments. These are all part of a suite of tools for especially in the university space, and then a few other assessment options as well. So we are deployed in many self-paced online courses. We are also part of a bunch of degree programs through boot camps. Boot camps are very, very popular these days. Being able to provide live ILT sort of environments that are robust and can be delivered simultaneously is really important. And then high stakes exams. We have a lot of universities using us for finals or for midterms, and so when large masses of learners come in to take these exams, we need to be able to provide integrations to lockdown browsers and provide kind of a safe environment there, and robust, of course. So in terms of cloud computing and how we manage and deliver credentials, we do as learners come in, if they require access to an AWS console or to GPUs or to an Azure environment, for example, we are providing each learner with credentials so that they can access those resources. We're not asking learners to put in a credit card or to set up the accounts. We're actually allowing them to SSO straight into the environments. And all of these accounts are constrained. So they're constrained by budget, policy, and session length. And that allows us to really provide access to specifically the resources and services that they need for learning, and then also to ensure that they are not exceeding the budgets for a given exercise. So we do invest a lot of energy on preventing overage or fraud. We are really proud to be part of this AWS Training and Certifications Academy program. And as of July 1st, they announced that they enrolled or trained their 1 millionth learner, and we are the platform to provide that training. We also integrate to other learning management platforms, including edX, and so along the lines of AI, large language models, Databricks has a course, two courses actually, that are teaching LLMs through edX, and thousands of learners have gone through that as well. And then similarly, through deep learning AI, there's also a generative AI LLM course that is being taught and leveraging AWS and Vocareum. So our integration to the learning platforms are typically through LTI or through a custom REST API. If you look at some of these on here, so Canvas is the largest deployment in the university space for us, and so lots of integrations there. As I mentioned before, Udacity, Udemy are edtech platforms that are using us, and they're using integration to Vocareum through our API. And then it's pretty much across the board. There's lots of different integrations there. And then academic partners, as I mentioned, we are supporting thousands of institutions, over 6,000 today. And so we are worldwide. And we have direct relationships with a number of these, and then also indirect through our partners like AWS and edX. So our AI notebook is a product that we launched a few months ago to deliver the hands-on AI learning. It provides cost-managed access to OpenAI credits and access to GPUs up in the cloud. So what that means, again, is that learners don't have to go out and set up an OpenAI account. They don't have to create an AWS account or a GCP account to get access to GPUs. Through our platform, we are providing cost-managed access. And we're planning to add more and more resources to the platform in the future to support other use cases. So in terms of the demo today, we will be covering a bunch of these scenarios, including the prompt engineering, being able to train or fine-tune models, and then the second point was to train fine-tune models using a GPU, and then also being able to fine-tune models through APIs through the OpenAI GPT 3.5 models. In terms of the problem that we are solving with our AI notebook, basically for learners, as I mentioned earlier, there's no need for them to create their own accounts or to provision GPU resources. There's no complicated setup to train these models. It's basically a single click access to the GPUs. And then for instructors or admins, being able to control the budget of the resources that are being consumed, and of course leveraging the most effective GPUs in the cloud. And then everything can be pre-configured and customized with all the proper packages and frameworks that you need for your work. And of course, the most important thing is no cost explosion, right? So, because of the way Vocareum set up, and because of our very tight management of the resources, there is no need for learners to necessarily worry about exceeding or or generating too much cost on any of their own credit cards, for example, or instructors being able to manage cost across the institution or across their class. So that kind of leads into the discussion about Vocareum Cloud Labs. And as I mentioned earlier, Vocareum is seamlessly integrated into all the infrastructure so that when a learner comes in, they will be assigned and provisioned an account, which they can get access to through our platform. Okay, so there's no need for them to create a new account. For AWS, we'll actually SSO them straight into the console if necessary. And so it really gives you the ability to gain hands-on experience with these cloud environments. Jupyter is our one of our most popular labs, being able to teach data science and analytics. Um, you know, so it's again, everything is delivered through the browser, hosted on Vocareum side, and it's appropriate for learning Python, R, Julia, C++, and everything's fully integrated. And then we do have quite a few folks who are, teaching digital skills, general digital skills, full stack development. So providing integrations, or not integrations, but environments that are based on VS Code or IntelliJ, MySQL, Workbench, kind of a broad range of tools and interfaces so that you can develop both the client and server side environments. And finally, we do have quite a few customers who are teaching cybersecurity. And so we will boot up a cyber range that can consist of Kali Linux, Ubuntu, or general Linux environments, as well as Windows environments. And so you can practice ethical hacking, conduct vulnerability testing and penetration testing. So really allows folks to be ready for cybersecurity. And finally, we are also really happy to be providing lab environments for Databricks. And in the last 6 months or so, we've been working very closely with Databricks to make sure that we can actually train folks on their data and AI platform. And of course, integrations, as I mentioned before, we are integrated to all the different LMSs through LTI, and then we do have APIs. So at this point, I'd like to pass the baton to Peter.
Okay, so hi everyone. My name is Peter. I'm a senior engineer at Vocareum and the lead developer for Vocareum's AI solutions. I'm once again here to give a demonstration about our latest advancement into the field of AI, what we call the Vocareum Notebook. This may not be the first time you've seen a demonstration of our AI labs, but there have been some exciting new developments, so please stick around until the end. So as we all know, there are, two pillars of AI education, OpenAI and GPU, and there are some challenges around providing these resources. And auto grading is one thing that we that we provide that is something that is necessary to help facilitate the learning of many users. Access to these AI and GPU resources, managing costs and budgets, and integrations to LMSs. So if you or your organization has struggled with any of these, we may be the solution for you. So in this demo, I'm going to be going over 3 ways to deliver OpenAI. We have our Vocareum notebook, our Jupyter Lab IDE, and using JavaScript to deliver it through purely an HTML / README example, and then a couple ways to deliver GPU. So once again, using our Vocareum notebook and our Jupyter Lab IDE. So before we begin, I just wanted to mention that everything you're about to see is in beta and is subject to change before release. However, the notebook is currently available now for pilot testing. And if you would like to experience it for yourself, then we're going to have a poll near the end where you can actually be enrolled as a student for this demo course that I'll be showing off. So you can go ahead and try out all the examples for yourself. So I'm going to start off here with auto grading. So for those of you familiar with using Jupyter notebooks on our platform, will know that we use NBGrader to set up custom auto grader cells, which are then run when a student submits their notebook. So right here, I have a very simple notebook that just goes over loops in Python. This is the instructor's view. And if I go down, you can see that there have been some solution cells set up, and then we have AutoGrader test cells. So these cells will be run when the user submits their notebooks and it does an assertion, then gives feedback back to the user. So I'm gonna copy this one solution just to use for the student view portion of the demo next. So this is the same notebook, but now this is from the perspective of the student. This UI is using our new Vocareum notebook. For those of you new to us, our Vocareum notebook is a completely custom, built from the ground up IDE, specifically designed to enhance the experience of learning AI. We all know that properly training a model does not come cheap, and one of the roadblocks for teaching anything ML AI related has been provisioning and managing resources to the learner. So this notebook is, again, built from the ground up, and let me go to, yeah, so this is the same cell. Here, the learner would put their code in to be graded. Instead, I'm just going to put the solution that I copied from before, and I'm going to submit the notebook now. It's going to take a few seconds for the grading to happen, but behind the scenes, we're performing the asserts and inserting these auto grading cells that are defined by the instructor, complete with any feedback the instructor provides, and these grades will automatically be passed back to the learner's LMS if that's been set up. This is a significant improvement over our current grading flow, where the learner would have to wait for a grading report to be generated, which could often take a long time. This is all possible because, again, everything's been built from the ground up. So adding in these custom cell types, such as these feedback cells, is now possible. And as you can see, this is the cell that I put in. You can see that it returns the correct value. Everything else I didn't touch yet, so there are no answers. You can see that we've got no score for them. Okay, next I'm going to move on to this is our OpenAI and prompt engineering notebook. So the next assignment I'll be showing will demonstrate our OpenAI integration. In the assignment settings, the instructor can set and enable a budget for OpenAI usage. For this particular example, I believe it's set to 10 cents. We're going to go over how to set these budgets after the learner experience portion of the demo. But again, you can see here at the bottom left corner, we have an icon for OpenAI, which also shows the budget. You can see that it is 10 cents, as I mentioned. And this is how much I've already used, just running a few demos already. And if a budget is enabled, every learner that enters the Vocareum notebook will automatically have a Vocareum managed OpenAI API key assigned to them, which they can access within the IDE using as the environment variable here. This can then be used with our Vocareum endpoint here, which will then forward the request directly to OpenAI. So I'm gonna go ahead and run these cells, loading in some packages. And one thing you can see here, so this is what we call our prompt cell type. This is again a custom cell type that is unique to Vocareum Notebook. That is possible because we can put in anything custom that we want. And what this cell type does is it takes a prompt, and then there are a few settings here. You can select the model, temperature top B, and it will basically forward the prompt request to our API server. We'll manage the budgets, check if everything looks good, and then we'll forward the request on to OpenAI. So I'm gonna go ahead and ask ChatGPT some tips on how to write a good prompt. So here we can see the response. And now I'm going to use those tips to basically compare the difference between a good prompt and a bad prompt. But first, let me reload the page. It looks like there was an issue starting the kernel. Let's run all these cells really quickly. So yeah, a bad prompt, an example would be something like AI in healthcare. Not very descriptive, of course. And what I do want to show is here you can see the budgets being updated in real time. So we've used a little over 3 cents here. And once the request completes, we'll see that the budget will be automatically updated. So yeah, it just went up a little bit. And then now we're going to ask it a better prompt. So could you explain how artificial intelligence is being used to improve diagnostics and treatment in the field of healthcare? Much better response, much more descriptive. And yeah, again, you can see that the budget has been updated. So if you're, interested in delivering prompt engineering, then the Vocareum notebook is a great way to do that with a very simple IDE as well as a prompt cell type to just directly converse with OpenAI. Now, the next example will be our GPU batch solution. So for the sake of time efficiency, I'm going to go ahead and start the training for this notebook because it's going to take a couple minutes, and then I'll go ahead and explain what I just did. Okay, so in this assignment, I have a couple notebooks that I'll be demonstrating our GPU integration. Once again, in the bottom left-hand corner, you can see at a glance the remaining GPU budget, which for GPU, it'll be in minutes. And the first notebook here downloads and trains a GPT-2 model that we get from Hugging Face. As we all know, training and tuning a model can take a very long time depending on the size of the dataset and the model being used, to the point where it would be infeasible to do so on the CPU. However, with Vocareum Notebook, we are introducing the ability to send training jobs to a separate GPU machine, which will run the notebook, execute all the cells, and save the notebook with its outputs as a separate copy. So for this demo, I've created a text file with around 500 Harry Potter trivia questions, which I will be using to train the model. This notebook will then save the model we created to the work area so that it can be imported and then used with our second notebook, which will perform the inference on the CPU. So it's going to take a couple of minutes, like I said. But basically, yeah, we're just downloading the model. We have our training functions, and then we're just training it on the 500 Q&A trivia questions. And just like the OpenAI example, we have the budget here, which will be updated in real time as soon as the job finishes. So the learner always will know how much budget remaining they have. Actually, while that's running, let me go ahead and start showing off the Jupyter Lab examples. Okay. So this Jupyter Lab example uses the Jupyter Lab IDE, as you can see, and it has the same two notebooks as the Vocareum notebook example, those same two Harry Potter notebooks, and it has the same functionality, except with Jupyter Lab, you can also specify a batch script, so a shell script to execute for users who want to be more specific, want to run something besides the Jupyter notebook. So I'm going to also run the same training notebook. Now going back to the other assignment, we can see that the training has successfully completed. And here in our work area, we can see that some models have been created. And now in the inference notebook, let's go ahead and run everything. So I just want to ask it a couple questions to make sure that it was trained properly on the data. So I'm going to be asking it, okay, what is a threshold, as well as name a Quidditch position. Okay, so I'm sorry about what just happened. The kernel seemed to not have started, so definitely a few reliability issues we're still working on. But let me just switch to the Jupyter Live example so we can go ahead and run it once this is done instead. And as mentioned, there was, okay, so job successfully completed. Okay, so this is the same inference notebook. Just run all of these cells. Oh, and once we run a job, like I said, we save a copy of the notebook with all of its outputs saved. So here there's a batch executions subdirectory that was created, a timestamp subdirectory for the job, and here's the executed notebook. So here we can see that all of the outputs have been saved. Download the model. And here this is just to show that we are indeed using the GPU for this assignment. We've used about 4 gigabytes. Going back to the inference notebook. Okay, so yeah, we see that the questions have been answered. What is a threshold? It's an invisible horse-like creature. Name a Quidditch position, a seeker. So yeah, this is once again to really demonstrate that the execution on the GPU has been separated out from the presentation, which is done on the CPU. And this allows us to really minimize the cost of running these GPU jobs, because we'll launch a server, only when a job is required, is in the queue, and then we'll shut it down afterwards. And we've really put a lot of energy into minimizing the cost. And one more thing I wanted to show with Jupyter Lab is here I just have an example shell script, some very basic commands. And yeah, you can also run, as I mentioned, any shell script. So this just gives the user a ton of flexibility in what they want to do if they want to do something batch execution related. And yeah, it should just take a few seconds. Yeah, so we have like an output file that was created. Once again, we have the subdirectory with the timestamp. These are the commands that were run. The final example I'm going to be showing off today is once again OpenAI related, but this time it's using JavaScript to basically deliver our API key. So this is a very simple demo that I've mocked up. This is also built from scratch, and it's just an input output. So let's ask ChatGPT how it's doing. Sends a prompt, and we get the response back. And once again, you can see that the budget was updated in real time. So this is just to show, so everything here, this is just pure HTML. All that you need to do is import a JavaScript library that we've created. And basically, because it's pure HTML, that means that it can be integrated very easily with, Canvas pages, for example. Can just be iframed wherever you want, and without the complexity of an IDE. And so yeah, this is our 3 ways of delivering OpenAI, as well as a couple ways of delivering GPU resources.